What's going on, guys? We're back at it, and on the last video, if you remember, we left off making the 2D colliders on our projectiles. And in this video, we're going to start with setting up our towers to shoot at our enemies. So hopefully by the end of this section now, we'll be able to see some projectiles flying through the air. Why don't we jump right into it and open up our tower defense project again. Everything should be very familiar. I'm sure we're all going through this relatively quickly. And one thing I want to do, let's see, we left off with making our buttons, placing the towers, and let's see, we made some prefabs for all of our projectiles. So you should see your projectile box here on the right side with is trigger marked on all three of them. All right. Now there's one more thing we need to do to get these guys ready, and that is making a script that we can attach to them. And this script isn't going to hold much. The only thing we need to have we need a couple variables kept track of, which we can set in the inspector, but we need to know the attack strength, and we also need to know the projectile type. And the reason we need to know the type is so later on in the game when we add sounds, we can reference that type. And the reason we want to give it we're going to use an enumerator for the type instead of using a tag. Pretty much that just allows us to just have one tag then for our projectiles. It just makes everything a lot easier. So why don't we start with that now? Actually, let's add a new tag. So if you have any prefab or any game object selected, if you go up to the tab or the tag window in the inspector, hit add tag, and hit the plus arrow, and we're just going to add one that says projectile. All right. And then let's go back to our prefabs folder, the projectile folder, and find our 3 projectiles, and go ahead and hold shift and select them all. And then let's set the projectile tag to all 3 of them. And then also the layer we want on the collision layer. All right, and I think that is good for now. Sorting layer, let's go ahead and put it on items. And we'll worry if we have an issue with it going behind things, we'll mess with the sorting layer down the road. Now let's go to our script. Right click and hit create new C# script, and go ahead and call this projectile. And let's open that up. And we don't need the start or update. It's kind of going to be like our button. It's just going to hold a game object, or it's just going to hold 2 variables for us. And the first variable we want is let's serialize, make it a serialized field. And we want it to be a private int, and this is going to be the attack strength. So each projectile is going to know its own attack strength, so that way when it hits our enemy, we can just reference the object that hit our enemy and subtract that from his health. And then our next variable will also be a serialized field, and it's private. And we need this to be an enumerator, which we haven't set up yet. I want this to be public though, so let's go ahead. You can delete the system collections up here, but let's go ahead and put our enumerator above this class so we can reference this enum anywhere in our project. And go ahead and say public enum, and we can call this, you can call it projectile type. I'm going to call it protype for short. All right. And all you do to make an enumerator in C# is write what you want. So we need a rock, an arrow, and a fireball type. All right. And then don't forget a semicolon at the end of the curly bracket. All right. So now our private variable is going to be type protype. Whoops. Protype. There we go. And let's go ahead and just call this, we'll call this projectile type. nice and long, but that's all right. All right, so those are our two variables, and let's create getters for them. We don't need any setters because we're going to set these in the inspector. So let's just make a public int attack strength with a capital A, because the private variable is lowercase and they need to be different. Oh, I forgot my T for integer. There we go. And all we're doing here is returning attack strength with the lowercase a, returning our private variable. All right, what did I spell wrong? Oh, silly me, I forgot to put get. You guys are probably yelling at me through the screen. So put get around that. There we go. Now we got our public getter. And we need to do the same thing for our projectile type. So go ahead, and this is also pro type. All right. And capitalize this projectile type. And make this a getter as well. And return projectile type lowercase. Okay, and I think that's all we need to do for the projectile. So let's go ahead and go back to our Unity project. And let's find our projectile prefabs. So prefab folder, projectile. And if we go ahead and select all three of these at the same time, we can hit add component, go down to scripts, and let's select projectile. And now you can see on the right side that we need to add a attack strength and a projectile type, but we want to do these individually, obviously. All right, so for our arrow, you guys, again, can make these whatever you want. I made our arrow 50 health points, so every time it hits our enemy, it'll take 50 health points away from them. And then our projectile type is arrow. And then for fireball, I made that 100, so it'll take away 100. That's our strongest projectile. And then rock, I also made 50. And the reason I made it 50 and then make sure the type is rock, the reason the arrow and the rock are the same, what I ended up doing is I made the arrow, the archer tower, the castle tower, be able to shoot faster than the rock tower. So we're going to set a delay, like, so the fireball tower, I think I said it can only fire every 2 seconds. And then I believe the rock tower could only throw a rock every either 1.5 seconds or 1 second. And then the archer tower, the castle tower, can shoot arrows more quickly. So I thought that was like a good way to make it a better tower without taking off too much health. And that's all we have to do for our projectiles. Now we need to create a script for our towers. Currently, our towers don't have any script attached to them, and our towers are actually going to control themselves. So when we create a instance or a game object of our tower, it's going to find the closest enemy and it's going to shoot at it. And so we don't need to control that from any one of our managers or anything like that. So we're going to go into our script folder and then select tower, right click that and hit create C#. And let's just call this one tower. And this is going to hold all of our tower stuff, just like our projectile. Let's drag our projectile into tower since it kind of has to do with the towers. All right, and then let's double click on tower, not tower button. And we're gonna have a brand new empty script here. All right, so let's think about everything we need. We'll start setting up our variables first. So like I mentioned before, we're going to keep track of time between attacks. So some towers can attack enemies quicker than others. So let's go ahead and make this a serialized field, because we'll want to be able to adjust this from the inspector, but we still want the variable private. And this will be a float. And let's just call this time between attacks. Okay. And then another variable that we're going to need adjustable, so make it serialized field. We need the attack radius. So, you know, how close can the enemies get to the tower before they can be hit? So like rocks obviously can't be thrown as far as an arrow, so we need to have the attack radius. So make that a private float as well and call it attack radius. All right. And let's think. We need a game object that we can have our projectile set to. So let's go ahead and make a private game object, and we'll call this projectile. Okay, and we're keeping it private. We don't need a serialized field above it because we're not going to be adjusting it outside of this script. Okay. And then let's see, we need a target enemy, right? So this is going to be type enemy since we're referencing this right here. Okay. And we can call this target enemy. And we'll set it to null off the bat because we don't want it set to anything until our code sets it. Okay, and now let's see. We need some sort of counter. So we need to keep track of the time in between attacks, right? So we need to have a counter that is counting. So let's go ahead and make another float, and let's call this attack counter. All right, so I think that is all the variables we need for this. Oh, I just realized we put game object here next to projectile. We want this to be a projectile, just like our enemies calling our enemy object. And that actually just helps us reference this script later on. So we don't want an empty game object. We already created a game object, and it's a type projectile. Okay. So we need to somehow know what enemies are on the map, right? So we're going to have to have some sort of like return, like get nearest enemy, right? In range. But we have to think about this a little bit. We don't know what enemies we have on the field right now, do we? It's yelling at us because we're not returning anything. So if we need to know what enemies are on the field, I'm just going to comment this out so we don't have an error if we run it. Let's go back to our game manager where we're spawning our enemies. Let's see. This game object, this is just the 3 different enemies that we have. We're keeping track of max enemies on screen, total enemies, and then how many enemies per spawn. But we actually don't know. Like, there's no way for us to, say, enemy that spawned first. We need to like grab that object and we need to know its position. So how can we keep track of that? We're gonna have to make some sort of method that registers an enemy and adds it to an array or a list or something like that. I think probably a list, and we could probably, let's see, we should make a register and a unregister method, because if one of our enemies dies or at the end of the round, we need to clear out all the dead enemies on the map and start the next wave. So we need to unregister and register enemies. And we also need to know which enemies are there because we have to remove their game object if they die. So why don't we start with making a list, and we can call this just, it can be private. No, it has to be public because we're going to have to access it from the tower. So let's make a public list. And a list, you just type list here and then less than, greater than. And it's a list of enemies. So just type in enemy here. So that's our object. And we'll call this our enemy list. And use capitalization for this one since it's a public variable. And then we just are going to create an empty enemy list right now. So go ahead and do this. Okay, so we have our empty list that we can add our enemies to. So we have our list. It's yelling at us because we need to Let's see if it'll tell us what we need. No, we need to import, I believe, system.collections.generic. Let's try that. Whoop, not user, using system.collections.generic. There we go. Now our list will work. And let's see, we have a remove enemy from screen, but I feel like we can probably get rid of that one because we'll let's see, register enemies, unregister enemies, and we don't really care if they leave the screen anymore. So we'll keep that there for now. Let's make a public void register enemy. And we're going to pass in a enemy object, and the name of this object can be called enemy. Okay, and the only thing this is going to do is add our enemy object to our list we just made. So enemy list dot add, and you just pass in the variable that we pass into this method, and there we go. So we just added a enemy to the list. So what this will be able to do, we'll be able to loop through this list and find the transform.position, and we'll know which enemy is closest to our tower, so we know which enemy we can shoot at, and that'll be really cool. And then, so right now we need a unregister also, so go ahead and call this unregister enemy. We do need to pass in a enemy object because this will be like if one enemy dies and we have to remove it from the list, we can call it directly, just passing in that enemy object. And this is as easy as saying enemy list dot remove and passing in the variable that we've passed in. All right. And let's see, when we unregister an enemy, we should probably destroy the enemy object as well. So just go ahead and type in destroy, and then inside the parentheses, you're going to pass in enemy, the variable, and then you're going to say dot game object, and that will remove the game object from the screen. And let's see, I think that's all we need for now for that. Let's make a field called destroy all enemies, because we're going to have waves, right? So you're going to be killing enemies. Some might be sneaking through, and when they leave the screen, they'll remove themselves from our list. So we'll have them on register. But what happens to all the dead enemies at the end of a round? We need to somehow remove all of those, right? So let's have a destroy all enemies function. All right, and we don't have to pass anything in because we'll just loop through our list and remove anything that's there still. So if this is called, it will wipe everything on the board, all the enemy objects, game objects. So do a for each, and of type enemy, and enemy will be the variable we're looking at inside of enemy list. All right. And so this will loop through, and every time, let's see, every enemy we find, we want to destroy the enemy object just like above. So enemy.gameObject. And that will loop through our entire list and get rid of everything. And then we also want to make sure that our list, once we remove the game objects, isn't storing any references to any of these empty game objects. So we're going to say enemy list dot clear, and that will remove and make it an empty list again. So that takes care of every scenario. So when our enemy spawns, we'll register them. When they escape the screen, we'll unregister them and destroy their game object. And then at the end of the wave, all the dead enemies, we'll loop through this for each loop, destroy the game object, and then clear the list when we're done with it. So it's an empty list for the next round. I think that covers all that every scenario. Where do we want to register our enemies? Now, we could register them in this spawn iteration, but I don't know if I like that. I think what might be better is if we actually were to do it inside of the enemy. So every time this object gets created, we can call the register enemy and register them right then and there. I think that, I mean, we could do it both ways. It would work both ways. I just think this might be the cleanest way. So let's see. We could register them right in the start here because this is called once. So every time this one enemy gets created, we can register them. And since our game manager is a singleton, we can just go ahead and say game manager dot instance and dot register enemy. And it's as simple as just passing this in, and it will pass this current game object. And that will give us a list of registered enemies. All right, I think we have some refactoring we can get done too. We have this silly enemies on screen thing, and we're just adding, every time we created one, we're just adding it. So we actually have a list now that we can just tap into the count. Let's delete all the enemy. So I just deleted enemies on screen plus equals 1 in our game manager inside of our spawn coroutine. So delete the enemies on screen plus equals 1. All right. And then also enemies on screen, we can now call enemy list dot count. And that, I mean, we already have our list there. We don't have to do any weird extra math where we could make a mistake in our code. And then let's go ahead and delete this remove enemy from screen because we have our unregister code now that will actually remove our enemies from the list. And then the list count will go down. And so that also means we can delete the enemies on screen variable at the top right here. So delete that as well. And, oh, I missed one. So this enemy's on screen, right on the first if statement, the first if clause. Let's go ahead and also call enemy list.count there. All right. So that's already better. All right, I believe we were referencing that subtract enemy from enemy when he left the screen. Let's just look through the enemy. So I'm in the enemy script. And the on trigger enter 2D collider where we're checking to see if the enemy is going to a checkpoint or if he's hit the finish tag. And the finish tag is our, the end of map. And we're removing enemy from screen, and we just removed that code. And we actually have a destroy game object here, which we're not going to need anymore. So delete that. And then instead of calling remove enemy on screen, let's call unregister enemy and pass in this, and that passes in this game object. And let's go ahead, save this, and let's run it to make sure our code still works the same way. Our enemies should march through and they should destroy themselves at the end, and we have to just make sure it doesn't crash or anything. All right, cool. So it looks like it's working the way it needs to work. And whoops, if we really want to make sure, well, if we really want to make sure I won't maximize it, maybe we should do this again, and we should watch the game objects disappear out of the hierarchy. That would have been the best way to test it. Okay, moment of truth. We should see these enemy 2 clones disappear, and look at that. So our code still works even with our refactor. So that's awesome. All right, now that we are keeping track of all of our enemies on stage, we can go back to our tower script where we started writing, get nearest enemy in range. And let's see, we actually should also make one that gets all enemies in range, right? So we'll have 2 broken out functions. We're gonna collect all the enemies that are in the enemy list on the game manager board. And if they're within our tower's attack radius, we'll add them to a enemies in range list, okay? And then we'll have that method return a list. And then the get nearest enemy in range, we'll go through that list and find the closest enemy. I think that will be the best way to do it. So let's make a private. And this isn't going to return void this time. It's going to return a list of enemies. So list type enemy. And then this will get, whoops, I am deleting things. And it's because I typed on my keyboard all weekend. I'm not used to my split keyboard anymore. So this is going to return a list of enemies. And we'll call this get enemies in range. And we're not going to pass anything into it because we have our public list. All right, and we have, let's see, we'll create a new list, a empty list of enemy, of type enemy, and we'll call this enemies in range. And this will just be a new list filled with the enemy object. And what we'll do is we're just creating this here because we don't need it. We're just passing it. We don't need it outside of the method that it passes to or calls. So that's why it's a local variable to itself instead of, you know, putting it at the top. It just saves some memory later on, and it's just something we don't need. So we now need to cycle through all of our registered enemies to find out if they're within our attack radius. And our attack radius is right here, and we're going to be adjusting that per tower in the inspector in a little bit. So let's go ahead and make a for each loop, and it's going to be of type enemy, and it's going to look at the variable enemy in the game manager dot instance dot enemy list. So this is where we're registering all of our enemies when they get created, right? Right. All right. Okay, so this is where we're putting them. And so this is actually going to be easier than you think. We're basically comparing it to the tower's position, and then we're going to find each enemy's position. And if the distance between the tower point and the enemy point are within its attack radius, we're adding it to this list, the list enemies in range that we just created right here, okay? All right, so I'm going to go ahead to get rid of these errors. I'm going to return enemies in range and get rid of our errors all over our screen. And it also helps to do the opening and closing parentheses, so it makes an empty list. I'm going to comment this out. Oh, we forgot. We only imported the systems.collections on the game manager. My bad. So system.collections.generic. Okay, now our list will work. I was wondering what was going on. All right, so like I said, we're just finding the distance between our tower and the enemy within range. So we need just a simple if statement and vector 2 because we're not in 3 dimensions. And then the distance, and this is just a built-in Unity tool. And you basically type dot distance and you put the two positions that you need. And if you just do transform dot position, that would be the position of the tower, because we don't have to name it. It's calling the object that we're inside of. And we need to find the enemy. So we're looping through the enemies in the registered enemy list. So we just need to say enemy.transform.position. And that will return our distance, right? And this is in our if statement. And we want to make sure it's less than or equal to the attack range, the attack radius of our tower. And if it is, then we're adding it to our empty list enemies in range. Dot add, and go ahead and pass in the enemy variable from our for each loop. All right, and we're done. That finds all the enemies within our tower's range. That's pretty easy, right? And then let's go ahead and finish off this get nearest enemy. Let's just uncomment this. All right, so the find the nearest enemy, let's go ahead and just make a variable of type enemy, and this is going to be called nearest enemy. And we'll start off, every time this function's called, this variable is going to be null, okay? And then we also need to make another variable called smallest distance. We need a reference. We need to know what the smallest distance is. So the first enemy, we're going to have a for each loop again. And the first enemy is going to be the smallest distance. And then obviously, if the next one's smaller, it'll be reset and it'll go from there. So it returns the smallest distance. And what we're going to set this to is float dot positive infinity. And so that's not null. That's literally saying it is a positive number, but it's like infinity. So anything compared to it is going to be smaller. All right. So our smallest distance starts off extremely big. And then so the first object that goes through our for each loop will set our smallest distance, and it'll go from there. And then after the for each loop, we'll know the smallest distance, and we can return that enemy object at the end. So go ahead and do for each again. And this time it's going to still be type enemy in our enemy variable inside of our, now here is where we want to call our get enemies in range. And we can just call that method directly because it returns a list of enemies in range. So when we call this, it is going to reiterate and go through this for each loop again and return all the enemies within our range. I think that's pretty cool. All right, so this is pretty much the same thing. We're going to now do an if statement and vector 2, and we want to find the distance. And the same thing, we want to find the distance from the tower to the enemy that we're cycling through in this for each loop. So we want to just say transform.position, and that's our tower's position. And then the enemy that is being compared to inside of our loop, we need to find the distance to his position. All right, and then this is a if statement. It needs to be less than the smallest distance. All right, so if it's less than the smallest distance, nearest enemy now gets set to the enemy that is in the list, right? All right, cool. And we also need to set our smallest distance as well. So every time it enters this if statement, that means it's the new smallest distance. So we have to set the same thing here. So this vector 2.distance, transform the tower position to the enemy position, gets set here. So go ahead and just type in vector 2.distance and then transform.position, which is the tower position, and then enemy.transform.position, which is the enemy position. And this distance is setting it to a float variable. And then all we have to do down here outside of our for each loop is return our nearest enemy. And now we have all the code in place to keep track of our nearest enemy. So we're going to end the video here. I know this was a lot of code, but we have a really good foundation. Like, a lot of this stuff is done now. And so in the next video, we're going to start seeing projectiles fly, and it will be really, really, really cool. So I will see you guys in a little bit.